This question is about density. It says that Kalpana finds a small stone. To help her identify the type of stone, Kalpana decides to find its density. Kalpana explains why she thinks this will help. She says the density will be the same, whatever the size of stone, as long as the type of rock is the same. Her friend Christine disagrees. She says that bigger stones will have a higher density because they are heavier. Now, this highlights a common misconception that students might have. They think that something that's dense, such as lead, is heavier. But density is not just to do with how heavy something is or the mass of it. It's to do with the mass in a ratio with the volume. So you could have two objects that one is lighter and one is heavier, but actually the lighter object could be more dense, but that would only be possible if it was very, very small compared to the other object, the larger, less dense but more heavy object. So it says, who is correct, Kalpana or Christine? Well, Kalpana is correct, but we're not going to get any marks for saying that. We need to explain why. And it's about discussing what density is. So density compares the mass of an object to its volume, or density equals mass over volume. And so as the mass increases, volume must also increase in order to get the same density. In other words, the mass and the volume have to be in proportion. Then it says Kalpana uses a measuring cylinder to find the volume of water displaced by the stone. She has 3 measuring cylinders to choose from. So we've got a 10 milliliter measuring cylinder with, it's got 5 lines in between the 1 and the 2. So that's going to be 0.2 is the smallest division. So I'm going to put 0.2 there as the smallest division. We've got a 25 centimetre cubed measuring cylinder, but here we've only got 1 division for every 5 centimetres cubed. So here we've got 5 being the smallest division. And then finally we've got a 50 centimetre cubed measuring cylinder, and there are 10 divisions between 40 and 50, so the smallest division is 1 centimetre cubed. Now don't be fooled here by the fact we've got a milliliter measuring cylinder and a centimetre cube measuring cylinder. 1 milliliter is equal to 1 centimetre cubed. It's just a different unit of measurement that handily means exactly the same thing. Now it says which measuring cylinder would give the most precise measurement. Explain your answer. So precision is all about measuring something to a smaller division. And so A is going to give us the most precise because it has the smallest scale division. For example, you could measure something that's a metre and you could just say that it's 1 metre. And if you had literally a metre long stick, you could make a pretty good measurement of that. But if you wanted to make a more precise measurement of that, you would want to get yourself a metre ruler with millimetre divisions, and then you could say that it was 1 metre and with precision of 1 millimetre. You know, you're not saying that it's 100.1 centimetres. You're saying that it is exactly 100 centimetres. So you're saying with more precision. So it's A because it has the smallest divisions. The The question continues and says, the most precise measuring cylinder may not give an accurate reading. Now, accuracy is about the measurement being close to the actual value. Now, if we looked back at these measuring cylinders, let's say that the stone was perhaps, even if it did fit in this one, sort of like this, if it fits in like that, then it's going to cause the water to displace over the top of the measuring cylinder. And so we're not going to be able to take an accurate measurement. So it's all very well being precise, but you've got to be accurate as well. So you need a large enough measuring cylinder so that when you drop the stone in, it doesn't cause the water to rise above the scale, let alone over the top of the measuring cylinder. So for part 2, we can say that the stone may cause the water level to rise above the scale. We could also say that we didn't measure it at eye level, and if we don't measure it at eye level, we're going to get a parallax error, and it's going to appear to be a bit higher or a bit lower, depending on whether you're reading it above or below the line on the scale. Okay. Now, with these sorts of questions, the exam board varies quite a lot as to what they accept. Sometimes it's when the size is outside the scale, but I think it's one of those ones where it's good to maybe write a few things to guarantee you're going to get the marks. So I'm going to also say that the reading may not have been taken at eye level. Then it says that the table shows the measurements that Kalpana makes. We've got the mass of the stone in grams and the volume of the stone in centimetres cubed. It says to state the equation looking density, mass and volume. So we've got density, the symbol rho, equals mass divided by volume. And then it says calculate the density of the stone and state your answer to an appropriate number of significant figures and then give the unit. So first, let's work out what significant figures we're going to have to use. We've got 2 significant figures here, 2 significant figures here, so we're going to give our answer to 2 significant figures. Then let's think about the unit. We're going to use grams and divide it by centimetres cubed, and that's perfectly fine. We could convert it into kilograms. We don't have to because we've been given the freedom to give our own unit. So we do density equals mass divided by volume, so 54 grams divided by 23 centimetres cubed. If we put that into a calculator, we're going to get 2.3, and it's going to be grams per centimetre cubed. Part D asks, how can Kalpana use her value of density to identify the type of stone? Now, this is one of these questions that I think students get quite confused at, because actually the answer is so simple that they spend so much of their time in physics exams really thinking hard, sometimes they forget the obvious things. So it's simple. Look up the density of some stones on the internet or in a book, and then compare the density of the stone that you found. So compare the calculated density with known values on the internet. The last part of the question says Kalpana may still be unsure about the type of stone suggests why. So again, this is sort of one of these ones which is quite simple really. You don't need to overthink it. It's just that there may be more than one type of stone that have the same density. So using density alone wouldn't be enough. You'd have to look at the stone and look at any sort of visual details that might help you in order to determine exactly what type of stone it was. So there may be multiple types of stone with the same density.